Okay, so now we're going to go over some more naming. We're going to go over molecular naming. So these are between two non-metals. So on the right side of the periodic table, let me pull the periodic table up here. So all this green area here, so it's between at least two of the green areas there. How you name these is you're going to have a prefix like mono, di, tri, tetra, penta, etc. Let me show you these. On the next slide you can see these. 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. It says drop last A if the name begins with a vowel. Okay, so you're going to have a prefix, those are your prefixes, the name of the first element, a prefix, name of the second element plus "-ide". Okay, so let's see what in the world I'm talking about. So for this first one here, we have NO2. Now there is a rule that if the first element is a mono, you omit it. Okay, so the name will never start with mono. So we have NO2. So we have nitrogen, and then we have O2. So we have how many oxygens? 2, which if we come over here is di. And then oxygen is oxide, so nitrogen dioxide. Let's look at the next one on there. So let's say we have, where is my mouse? Oh, plug it in. That would help. If we have, okay, N2O, we have dinitrogen, because 2 nitrogens, and then mono oxide. Monoxide, and this should be 1O, not 2. So dinitrogen monoxide. You see here. Let's look up some more examples. Let's do Ni3. So Ni3. So it's never going to start with mono, so it's just going to be nitrogen. There's 3 of those, so it would be tri. And then iodine would be iodide. Nitrogen, let's look up here. We have P4S10. P4S10. 4 is tetra. So tetra, P is phosphorus. Phosphorus. And then 10 is deca. And then S is sulfide. So you have to put how many there are. So, di, nitrogen, meaning 2 oxygens, mono, oxide. Remember, we never start the word with, or the name with mono, so this will just be nitrogen, tri-iodide. Let's look up one, let's look at like CO2. This is carbon. Oops, if I can spell, that's a B. Dioxide. Right? Di meaning 2 oxygens. Or we do CO, which is carbon monoxide. Okay, so these are, I think, a lot more simple than the metals. Let's go backwards. So let's look here. What if we had phosphorus pentachloride? So phosphorus, that's P. Penta is 5, and chloride is Cl. So that would just be, actually, let me just type this down here, it'd be easier. PCl5. Look at the next one. Nitrogen dioxide, that's NO2. Is nitrogen, and mean 1, and then di, 2 oxides. So that's how you name molecular compounds. And remember, molecular are between 2 nonmetals. There's no metals in these. Let's look at acids. Acids are a little bit harder, but they're not too bad. Again, there's a chart you need to memorize, but that's it. Okay? Acids, they release hydrogen, H plus, in water. Okay? So it's a hydronium. How to identify them? They'll have an H at the beginning of the name, plus a nonmetal, and the word acid in there. There are two categories, binary and oxyacids. So again, if something starts with an H, it's pretty much going to be an acid, okay? And in the name, it'll have the word acid in there. So let's look at this. If we have a binary acid, these are really simple to name. It's just going to be hydro, the base name of the nonmetal, ic acid. So for example, we have HCl. Notice it starts with H, so we know it's an acid. So that'll be hydro, and then the base name of the nonmetal, which is chlorine, but we're going to name it an ic, so hydrochloric acid. And this next one would be hydrobromic acid. And let's say, let me put down here, HF. If we have HF, that would be hydrofluoric. I can't spell, apparently. Let me spell this correct. There we go, hydrofluoric acid. Let's look up HI. This would be hydroiodic acid. Okay, so your binary acids are just going to be with your halogens. Remember group 7? Right here, group 7. So hydrofluoric, hydrochloric, hydrobromic, and hydroiodic. Those are going to be your binary acids. So that's the first way to name them. So not too bad. But then we get into the ones that are a little bit more challenging. And I made up this chart to hopefully help you. Okay? So you're going to look at the polyatomic chart. So where it says anion name, that's your polyatomics. And then this will convert it to the acid name. Okay? So if we look up on the polyatomic ClO minus, just not with the H, but ClO minus, that is called hypochlorite. Okay? So again, let me type down here, ClO minus. This is hypochlorite. Okay, that's what it says. This is what the anion name is, hypochlorite. But as an acid, because now it has an H in front of it, we name it, putting it right here, hypo. We keep the hypo, except now it becomes chlorous acid. Okay, so hypochlorous acid. If it ends in ite, so like ClO2, which is on our polyatomic chlorite, it now becomes chlorous acid. I can't type. Acid. So right here, chlorous acid. So it's an and then ClO3 is on our chart chlorate, and now becomes chloric acid. You see that 8 becomes ic acid, and then HClO4 was perchlorate, okay, but now it's perchloric acid. Okay, so the last two will end in ic acid, and the ones in the middle, if they end in 8 as a polyatomic, they'll be an ic acid. Sorry, 8-ic, and then the it will be an us acid. So let me go back to the polyatomic chart, and let's just look at all of these. Oops. Nope, there it is. Okay, let me make this bigger. Okay, so we said 8. Let me make sure. 35. Let's look at our little chart here. 47. Ite is an us, itis, an adic. Itis, adic. Okay. So let's come back here. ite. So let's look at the ites. You see this is like chlorite. Now it becomes chlorous acid. Ite. Okay. Ite becomes an us acid. And an ate becomes a ic acid. So let's look at your eights. So there's a lot more eights than there are ites. So bisulfate would become bisulfic acid. Bicarbonate will become bicarbonic acid. Dichromate would be dichromic acid. So basically everywhere it says ate, you're going to erase that and put ic acid at the end. Okay? So a perchlorate will become a perchloric acid. Nitrate is nitric acid. Sulfate is sulfic acid. Or it really would become sulfuric acid. Okay, now let's look at the ites. All of the ites will become an us acid. So if it was an ite on here, so like chlorite becomes a us acid. So chlorous acid. Here's another one. Hypochlorous acid. Another ite. Here's a nitrous acid. Okay? So the difference between nitric acid and nitrous acid is what it ends in. Ate is your nitric. Ite is your nitrous. So let's do some examples. Okay. C2H3O2. So let's find C2H3O2 on our polyatomic. I believe it was on 35. Yeah. Move this over a bit. So C2H3O2 minus. This is what that was. That's an acetate. Okay? Acetate. So it's an 8. So it's going to become acetic acid. Instead of 8, it's going to be ic. So acetic acid. So your first one is acetic acid. Okay, let's look at the next one. HNO3. So we're going to look up NO3. Remember the H just means it's an acid. The H tells us to convert it to its acid name if it begins with an H. So let's see. Let's go back up to here to 35. And let's find NO3. NO3 is a nitrate. So that's going to be an ic acid. So that means it's going to be nitric acid. Okay? So I hope this makes sense. A little bit. At least, obviously. So if you see an H in front of a name or in front of a compound, that means it's an acid, and you need to convert it to its acid name. So look what is called as a polyatomic. If it ends in ate, ATE, then its acid name is going to end in ic acid. If it ends in ite, ITE instead, its acid name will end in us acid, OUS acid. Okay? So let's go backwards. Just write the formula. So we have sulfurous acid. So an us acid, or let me just write these up here. Sulfurous acid, and then what was the other one? Perchloric. I added another O in there. Perchloric acid. Okay, since this was an us acid, us, I know its original was a what? Ite. And since this is a ic acid, I know its original was a ate. So let's look for sulfite and perchlorate on our chart. Okay. So we're looking for, what was it again? Sulfite. So SO3, 2 minus. SO3, 2 minus. Again, that was right here, sulfite. And how do I know it was sulfite and not sulfate? Because this was a, look over here, an us acid, so it had to be an ite. Your us goes with ite. And the next one is ic, and that goes with 8. So we're going to look for perchlorate, which is here it is, perchlorate. ClO4 minus. ClO4 minus. Okay, now let's put our H, because we know it's an acid, so we put our H in front. Okay, now it's, look, H always has a +1 charge because it's in group 1. Okay, now let's look at the bottom one because it's the easier one. You see a +1 will neutralize a -1, so we don't have to do anything with it because it's already neutral. So HClO4, that's perchloric acid. Okay, now let's look here. HSO3, we have a 2 and a 1. So we need 2 of these to make up for that there. So this one will actually be H2SO. Okay, so hopefully that makes sense. Let's just summarize all of the naming rules. Chapter 3 is pretty massive. You first learned the difference between the different formulas, molecular formula, all of those. And then you learned how to convert from a gram to a gram. Okay, remember that goes from grams, then you convert to moles of A, to moles of B, to grams of B. And then we looked at the percent composition and how to find out the formula from the percent composition. Then we looked up naming, and we did metal naming. So first was main group. So the difference between main group and transition metal is that parentheses Roman numeral. Remember, the main group does not have a parentheses Roman numeral, okay? But the transition metals do. And then we learned how to do the molecular naming, and that's when we have the di, tri, tetra. And then we have the acid naming. And that's all of your naming, okay? Now again, they're not necessarily hard to do. It's just memorizing the rules and knowing when to apply each rule. So it's just kind of tedious and everything. So go over naming, do a lot of examples, and just like with any lecture, if after you listen to my lecture and you work out examples, if you're still missing them, please let me know, and I can make a vodcast where I have more examples in there. But I won't know to make more if you don't tell me. So try first on your own, and if you're still failing, let me know so I can make more. Okay, that's the only way I can support you. So good luck with naming, and you're almost done with chapter 3. We just need to learn how to balance equations.